So before that, before getting into the next session, right, I want you guys to, if you have been part of this party since we started the 20th of March, just a word or a phrase on the chat. A word or a phrase. Just tell me how you have felt. If you have gained anything, whether it's been great or interesting, whatever. A word or a phrase. I don't want a sentence. Please, I don't want a sentence. Just a word or a phrase. On the chat box, please. Enlightening from Didi. Eye-opening from Chiaka. Okay. Mind-blowing from David. I love that. Great search from Chidube. Pate says awesome. Abel, insightful. Okay, Andy, informative, awesome. Ugo, you said empowered. Awesome, awesome. Exceptional teachings, understandable. I love that. Fantastic from Chinwe. Fantastic session on my coconut head activated. Martins, I love that. Dollar or empowered. Great, great. Keep them coming, guys. Keep them coming. Keep them coming. We want to get all those feedback. You know, just to be sure that this is really impactful, right? If it's not impactful, we just end the session right away and everybody can just go home. Informed, Phillips, coconut head, don't reset. Chinwe. Hey, take it easy. Dollar or increase confidence. I love that. I love that. Let's keep them coming. Let's keep them coming. Let's keep them coming. What are the feedback? I just want to see the feedback to be sure that this has been informative. Demila, oh, look at you. I just said informative and right away you said the same thing again. Same. Motivated. I love that. I love that. I love that. I want to see more feedback, more feedback, more feedback. Guys, you can see that my voice is almost gone for the past couple of days. You guys have to make it easy for me. So, inspired, Oluwaseun, JT said transforming, charity inspiring, educative from Kenny, can do it from Adebayo. This is well coordinated and first Martins. I love that. Dollar were exceptional. I mean, you guys are awesome. You guys are the best. I love the feedback. And I love the fact that you guys have found this very, very, very informative and educative. Because the truth of the matter is that when you cook a very, very delicious pot of ewedu soup and amala, you know, when you finish cooking all this, you need people to come and eat. You can't finish all by yourself. So you want by after cooking all this and the people you invited for the party do not like the food, everything goes to waste. So, but what you guys have said is that the ewedu, the wegiri, and the amala that we have been preparing all this while has been very, very sumptuous. That is really what you guys are saying to us. And I really appreciate that. I really appreciate that. Thank you so much, guys. Thank you. Thank you. All right. I'm seeing the hands. Olayemi, do you have a question?
Sorry, it was a mistake. I wanted to type something, but it's put up a question, but I've really enjoyed myself throughout the program.
Excellent. And the coconut head is fully activated. Yes or no?
Thank you, sir. Yes. It's fully activated, sir.
Awesome. I love that. I love that. Okay, great. So let's go straight into this, guys. Today we'll try to see if we can wrap up on time as well. You know, we'll see. Probably we'll just do like 2 hours and wrap up. But I know you guys, we have tons of questions for the man that is coming on board tonight. You know, we are blessed in our ecosystem. When you talk about Black Tech, you talk about the community, you talk about men of timber and caliber, you talk about great faculties, you talk about great personalities. You know, today we are delving into networking. And there's a guy that, you know, when you talk about networking, this is something, you know, the guy, this is something he enjoys. He's so passionate about it. You know, this session, we would have even postponed this session. When I had conversation with him, there were a couple of things that came around that was, you know, kind of threatening the delivery of this session today based on schedule and some other things that came up. But he said to me, no, we are not going to postpone it. He said, no, don't worry, we're going to deal with it. Mr. Encouragement. is a passionate guy. Incredible. He has mentored and supported so many within our ecosystem, NIPCA ecosystem. He has empowered so many. Today, many have delved into cybersecurity, networking because of this guy. He's a guy that is an encyclopedia. You are asking for resources, materials. Before you ask, boom, you receive. That's the kind of person he is. And we are blessed to have him tonight, as he delve into the world of networking. As he delve into networking, to break things down for us, help us to make sense of all these things. Sometimes you're talking about IP address, you're talking about routing, you're talking about switches, you're talking, you'll be like, which one is switch again? Is it the switch on my wall? Which one is routing? Which one is IP address again? There are a couple of jargons and terminologies that sometimes are so confusing, right? So tonight, Wenga is going to help us to do justice to some of this, okay? Having said that, let me mute everyone because of some of the noise at the background. 1 second, please, everyone. Okay. All right, so everyone is muted right now, and we can have Mr. Encouragement. Mr. Bwenga, please take it away, okay? Do your thing, and I know the participants have got a lot of questions. This journey is not an easy journey, but we started with over 200, for the last couple of weeks in the IT Foundation, over 200. But today, we are getting to about 100 and something. That is to show you that, and we keep saying it from the beginning, for you to pivot into tech and earn those 6 figures, those high salaries, you need to activate what? The coconut head. Without the coconut head, that coconut head must be fully activated. And I'm excited today that we have so many people on this session tonight that have fully activated the coconut head. Mr. Encouragement, please take it away. Thank you.
Thank you very much, Oscar. And I just want to be sure that you can hear me.
Yes, we can. Yes, we can.
Thank you. I want to say a great thank you to Black Tech and the organizers for all that you guys have done. I count this a great privilege to be invited here to share part of the things I've learned in my little life with the audience here who are either trying to start the journey of IT or who are in other department, in other areas of life, trying to transition into IT, or some people might be here that are in IT and they're looking to upskill. So my name is Oluwagbenga, and I'm popularly called Mr. Encouragement, and I'll just be sharing with us today some of the things, like I said earlier, some of the things that I picked up in my career as I was journeying through life. So I won't waste our time today because we are going to be building we're building something. We are starting from the core, and then we'll take it all the way to networking. So it's going to be very interactive. I'm going to make this very engaging. I'll try to make it much more engaging. So if you look behind me, there's a whiteboard. So so we're taking this like back home. So if you have questions, feel free to put your questions in the question box in the chat. So I'll be more than happy to take questions on the go. Oscar, you want to say something? Okay, so I'll be more than happy to take questions on the go. So let me go ahead and share my screen and see if you all can see my screen. Just one moment.
Yeah. So just like as Mr. Wenga have said, of course, you all know the drill by now. When you have a question, please feel free, use the reaction button to raise your hands, okay? You have any question, raise your hands with the reaction button, and I will unmute you, and allow you to ask your question. Okay? Because we just like we said at the very beginning, we are treating you guys like babies, right? So we're not going to wait till the end of the session to ask questions. You have a question, raise your hands, and you get the clarification so that things can make sense even at the beginning. We don't want to wait till at the end before you ask the question. No, let's take it gradually and slowly with you guys. Okay? And of course, Mr. Wenga is also going to do that. He's going to break things down in a very, 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 very granular levels. He's not going to be going so deep, that you guys will not be confused. No, trust me, he's going to take it easy. Okay, Mr. Wenga, over to you.
Thank you very much, Oscar. I appreciate you, sir. Just as I was saying before, part of what we're going to be doing today is we are building a concept. We are actually going somewhere. I'll be taking us through a journey of from zero level, from what the computer is, what makes up a computer, the hardware part of the computer, the software part of the computer, the operating system, what are the different operating systems, what do they do, and before we get to the networking that I'm very passionate about. So without wasting much of our time, permit me to take this seat away because I can only sit. Part of what Osa was trying to say earlier was because Osa permit me to share this. I've been dealing with some medical things that I have to do with my back, so I can't sit for longer than 10 minutes. So the rest of this will be on my feet, if you guys don't mind. Let's get to it. All right. Okay, so I'm sure you guys can, let me make my camera come up a little bit so you can see my face. Okay, I'm sure everybody can see my face. So talking about some of the things we're going to be going through today. We're going to be talking about what is the computer hardware and software. So I'm sure that before today, we've been through a lot of things in IT as part of this program. So I'm not going to take much of our time. I'm just going to use a few things to demonstrate to us what the computer software and hardware are. If we talk about computer hardware and software, those are two different things that makes up what the computer is. One is the one that is you can touch and you can feel. Like I'm having here my wireless mouse, that's the hardware. I have in my hand here my wireless keyboard, that's the hardware. I have another mouse here. I have my docking station, that's the hardware. I have my hard drive, that's the hardware. I also have here this is the regular 2.5 inches HDD hard disk drive. This is my solid state drive. You can ask questions about them later. I'll be more than happy to answer those questions. If you can hear me, let me just see you give a thumbs up. If you can see me better, if it's okay, please, if you need me to adjust my microphone for any reason, just put something in the chat and also will let me know. So to move us further, this presentation is actually is going to be based on telling you about what the computer is and what makes up a computer. What are the features of a computer? What makes hardware and software very important to IT world of today? Okay. Okay, I will just go on. So what are the various types of computers? I'm sure every one of us right here, let me show you one of my favorite guys here. Okay, so I've got one of my laptops here. This guy has a docking station. So this is a laptop. And I'm sure a lot of you are sitting on a laptop right where you are. I got my, let me see, that's not with me here. So I know some of us who are on this call might have seen the maybe in the 90s or in the early 80s, you've seen some very massive computer chassis that is this big. And if you consider what we had then with what we now have, you'll be shocked that what runs on your phones is more powerful than what used to run on those pieces of metal. Okay, so a computer is a device that transforms data into meaningful information. Of course, it processes the input according to a set of instructions that you provide to it. I'm sure all of you remember that word. What you give to a computer is what it gives back to you. There's a way we used to say it back in the day. So, and you know, for some of us who are also have been around for a while, you know that there were times when you could not. Let me choose my word carefully. There are times when we used to, especially for some of us who are in Nigeria right now, there are times when you used to write your letters on paper, or you write your whatever you want to go and type. You write some paper. You take it to a business center, and then they help you process it. They type it. I think some people are putting some things in the chat. Thank you. Yeah, that's the garbage in, garbage out. That's the word. Yeah, you're right. I was good. I was actually going to ask a question about that. So, and you know, you take those everything you've written out, you take them to those business centers, and all they do is someone sits behind the computer and type it for you, and you proofread it, and they print it out for you. Okay. Now, I'm building a case, and I'm going somewhere. So, I mean, depending on the side of life that you are, like depending on our ages, some of our fathers saw the supercomputers. Some of our uncles saw the mainframes. Now mini computers are what most of us are getting to see, and workstations, and of course laptops and PCs, palm tops back in the day. So, I mean, what am I trying to say? I'm trying to talk to you about the evolution of the computer, system, from what it used to be, something that is so massive and so big, bigger than the size of this room that I'm in, and it's going to take like 30 or 35 people to send data across the old machine. You bring it, I pass it on to you. You take, I take. Okay, we're trying to form letter. We're trying to write. Let's say we're trying to write something. Let's say we're trying to write hello world. So hello world. Andy on this call will try and bring something that will some things that will make the H. Dollar Paul will be trying to bring the E, and all of us will be working together to make sure that we get the word out, hello world. But today, you don't even have to type. All you need to do is Siri. All you need to do is Siri. Type or whatever. Just use the voice, and that's it. So, and I'm sure some of us on this call, I'll get to this. I don't want to preempt myself. I don't want to go ahead of myself, because there are some technologies that are coming in now that is so crazy, and I'll try and show us some of those technologies. Let me see my slide. What's going on here? Are you going or you're not? It's like my slide is stuck. All right, let me see. Yeah. Okay, cool. That's fine. Okay, cool. So what are the various types of computer? I mean, I actually preempted myself there. Of course, there's the analog computer and there's the digital and there's the hybrid. You can reference that on the link that is put in there. Okay, cool. I had gone ahead of myself to show you some of the things I would call the hardware. If you see up there, you can see from the top left, you can see what the fan looks like. That's the computer fan. That's what we call the cooling fan. That guy sits on what we call the heatsink of our microprocessor. So the heatsink is what sucks in the air that sucks in the heat from a microprocessor, what we know as the CPU. So if you look somewhere around here, fantastic. So you see what we call the motherboard. The motherboard is, I don't have my piece of motherboard here. I should have shown you. So the motherboard here is like it's like, how do I put it? It's like the brain box of the computer system that everything connects to. Everything connects to. So on that motherboard is where you have the controllers, the buses, everything that every other hardware needs to operate with. So on the right side of my screen here, where you have the CPU, you have the heatsink, and just so you know, let me ask you a question in this chart. Please, if you see let me see if I can annotate here. I promised you I was gonna make this very, very interactive, right? Let me see if I have the option to annotate on my, I don't have that option, unfortunately. Okay, so let me see.
Is it to annotate on the Zoom?
On the Zoom, yeah.
Yeah, you can. Can you check?
It's not showing for me.
So at the bottom, you can see the.
I don't have the annotate option. Yeah.
You don't have it.
I don't have it.
1 second.
Let me move this for you so you can see what I'm saying. So it should be somewhere around here. It should be on these options.
Okay, keep going. Let me check and see what's there.
Okay, that's fine. Thank you. All right. So let me ask everybody on this call this question. Look to the left side. The left side is where I have this. I have the floppy disk, I have the heatsink, I have the hard disk, everything pointing to that guy in the middle. In the chart, don't say it, just type it. What is that thing called in the middle? Olufunlayo, Dolapo. Okay. Okay, I'm seeing all your responses. Now, okay, fantastic. I'm seeing all your responses. Okay, CPU, desktop, okay, casing, okay, OS, fantastic. Great answer. All right, so let me quickly explain something to us. I appreciate everyone that participated, and if you call that a CPU, yes, you'll be wrong. You'll be wrong because it is not the CPU. It is the chassis. If you call it casing, you'll be right. Okay, so we call it computer chassis. It's like the case where you're putting the motherboard, and then after you put in the motherboard, you look for your for the kind of CPU, central processing unit, which is this guy on the right, that is next to the heatsink. So the CPU goes, and you have another one here on the left side too. The CPU goes on the motherboard goes into the casing, which is the chassis. So the hard drive goes in there, the power supply goes in there, the floppy drive goes in there back in the day, right? The optical drive, which we all know as the CD-ROM drive, DVD-ROM drive, DVD writable drive, or whatnot. And then what else goes on there? Of course, you're going to need your RAM to ensure that you're able to boot the system, obviously. So that is not your CPU, that is the computer chassis or the casing. Okay. Thank you for everyone. Thank you to everyone that participated. Yep, it is not CPU, but it is the casing. So let me quickly break a few things down. One of the most essential components of the computer itself is the motherboard, like I explained to us before. And you can see on the slide that CPU is mentioned, RAM is mentioned, the input and output system is mentioned, the power supply, the video display controller, and the buses and the hard disk. So let me do a quick breakdown of all of this. Imagine you have a car, right? And your car does not have that, I don't know what it's called, it doesn't have that part of the car that joins the front wheel with the back wheel, right? And it doesn't also have the bar that goes from the front to the back. So what that means is you don't have a car. You have, maybe you have a bicycle or a moving maybe a cart. Oh, someone said bungalow. Yeah, thank you, Tosu, for saying that. So it's like you having that kind of a wheel or a kind of a trolley or something that has 4 wheels. But this is what we're talking about here. If you look at the motherboard, like I said, is what puts together everything that a computer needs to be able to talk to each other. Everything that the computer needs to be able to talk to, all the components of the computer rather, needs to be able to talk to one another. For example, I have a keyboard. There's an input device. If you take note, the keyboard is not on this slide. Yeah, so the keyboard is going to be an input device. My mouse is going to be an input device. But guess what? Without my motherboard, I don't have a computer. If I have my motherboard, I don't have my CPU on it, I don't have a computer. And guess what again? If I do have a motherboard, I have my CPU on it, I got my hard drive on it, I have my DVD burner on it, I got my power supply on it, I got my heatsink on it, I got my video card on it, I don't have my memory card. Boom, I don't have a computer because it's not going to turn on. So it's like you having everything that your car needs, right? And you have a battery and you don't have the terminal on the battery. You get what I mean? So you have everything that the car needs. You have the battery on it, in it, and everything, but the terminal is supposed to go on the battery edge. You took them out. So there's no way your car will start. So if I take the battery of the car out, it's like me taking out the power supply of your of the car, right? It's like me taking out the power supply of the computer. So now another thing I wanted to share with us is this. If I have a car and I have a radiator, okay, what about GPU? Thank you, I'm going to answer that question. So that's for your graphic card. So if I have a car and I have water in my radiator, right? And okay, let's put it this way. I have my car, I have water in my radiator, and I don't have the fan. You know that fan behind the radiator? I don't have that fan. What happens if I drive that car, let's say I drive that car for like 5 kilometers? What do you think is going to happen? It's going to eat up. Thank you. Exactly. So that is what your heat sink and the cooling fan is to the CPU, which is that guy in the middle right there. I believe I've been able to do justice to this. Let me move further, and then we can, if you have questions, like I said, this is going to be very, very interactive. I'm ready to scribble, to show you everything on the whiteboard. So let me get going. Let's see. All right. Without me reading what's on the screen to you, I've actually gone through everything that is on that screen. But to briefly just explain, I remember back in the day when I used to build computers, when I'm sure some of us here on the call would, almost everybody here would know Computer Village, where we call it that. If you are not in Nigerian on this call, I mean, you may want to Google it and see what we call Computer Village. I remember back then, what I used to do is we'll go to the Computer Village. We're gonna go and clone computers for people. I'll buy my chassis somewhere in the days of ATX casing. Oh, fantastic, BIOS, good, we're getting there. I like that one in the chat too. So I'll buy my chassis somewhere. Don't forget the chassis is a case. So it's either then it was ATX or AT back in the day, but let's choose a form factor. Let's say the form factor is ATX. And please, when I say form factor, you can Google it real quick. It's like, how do I explain that to you that you will get it easily? It's like you having a freezer, exactly. You having a freezer that is 6 feet wide and 3 feet in breadth, right? So in length and breadth, 6 and 3. And you want to put like a carton, like a big carton into it. Mathematically, you'll be able to fit in anything that is not more than 6 feet and 3, right? If you have 5, 2, it goes in easy, right? So, but if you have 8 and 5 without going into the freezer, no. So that's the best way I can explain the form factor. So the form factor is for the computer is, okay, if I have this motherboard, if I have this casing, if I have an ATS casing, a smaller casing compared to an AT casing, I'll show you pictures of that, and I'll also put some of that links in the chat for you. Back then, we used to have what we call ATX motherboard and AT motherboard. So an ATX motherboard is smaller, okay? Just give me 1 second. Let me see if I can put something in the chat for you guys. Like I said, I'm going to make this very, very interactive. Versus 18. Just give me 1 second. Okay, this is a good one to look at it. All right, I'm putting this in the chart for everyone to see. That guy. So just take some time to look at that. But what I'm trying to explain to us is in terms of the length and size, one is a lot bigger than the other one. Okay, so back then I'll buy my motherboard somewhere, buy my casing somewhere, and then I'll buy my RAM somewhere else. I'll buy my power supply. In fact, back a lot of the motherboard we have what we call open motherboard, and we have integrated motherboard. Open motherboard is where you just get the motherboard, you go get every other thing in pieces. Like you get your CPU. Remember that picture you had before in here. Let me take you back. What we used to have as integrated motherboard is you have your motherboard, you have the CPU, you have the heatsink and the fan. on that motherboard. In some cases, we also used to have your graphic card on there. Then we also used to have the NIC card, network interface card. For some of you that don't understand these things, don't worry, I'm going to break all of these things down. Thank you. All right. So let me move forward. Okay, so the motherboard is, like I said, is the central nervous system of the computer. Every critical component of the computer does what? Connects to the motherboard. This CPU, that's what does the processing, the algorithm and everything, all of that is done by the CPU. Okay. Now the RAM. So I'm going to ask a question here for you guys to tell me the difference between the RAM and the ROM, because you've seen it's there, but I'm going to ask the question later. So the RAM is what the computer needs to operate at the moment. You get what I mean? Like random access memory is what I need to run at the moment. Okay. It's more like, how do I put it? You start your car and then you begin to drive, and then the gas the fuel that you use between point A to point B is what you use during that time. The moment you turn off that car, what happens to your fuel? It goes back out of the what's it called? The hose, and goes back to the tank, right? Now, but if you start the car again, what happens? The fuel, whatever it is that is getting the fuel out of the tank, we start to get the fuel out again for you to drive the car. All right. Now, talking about ROM. ROM is what you know as the read-only memory. It's like it's of course it's bigger in size. Thank you, Dimladi, for saying that. Yeah, the ROM, you just took that out of my mouth. The ROM is calculated and bigger in size. I mean, if you use your computer is having like my computer is having 32 gig RAM, and I'm sure a lot of people have 64 gig for guys who are gamers. And if you are doing extensive server environment, you're talking about 256, 512 in terms of gigabytes of RAM and all that. So your hard disk is a ROM. This guy is a ROM. This guy is a ROM, and of course the RAM is random access memory. We cleared that earlier. And let me move further because we are going somewhere. Okay, so the number 4 on the list is the input and output system. Now, these are the hardware components that requires human beings to relate with the computer. And give me an example here of what you need to relate to the computer. Put it in the chat. I mean, you're staring at the screen of the computer. If there's nothing, what is that interface between you and the computer that allows you to, thank you, keyboard, thank you, what else? The mouse, thank you, what else? Yeah, keep it coming, keep it coming. Yeah, keep it coming, keep it coming. It's right there. And then for some of you that are gamers, you'll be talking about the controller. So that's also things to talk about when we talk about input and output. Sorry, I mistakenly turned on my my game. Sorry about that. We'll have to turn that off. Sorry about that. Okay, so number 5 is power supply. 5 power supply. And like I told us before, if you have a car and you don't have a battery in it, what happens to your car? It won't start, it won't move. Then there's a note for everyone. It says that all these components come together in order to ensure that a user or other systems can connect, communicate, and process data in a basic computer system. However, different computer systems have other unique components and specifications depending on the brand, model, the intended workload, and usage. It is essential to define the usage before purchasing a computer system. This is one of the questions I used to ask people when they're buying computers back then. Marilyn, I'm going to answer a question, and I'm coming to that right now. Okay, so when buying a new computer, what is most important, the RAM or the ROM? That's the question from Marilyn. So I'm going to use Marilyn as an example, and I'm going to use Demilade Ogo as an example. So let's say Marilyn and Demilade are siblings. I'm not going to name who is older, okay? So don't worry. So they're siblings, and one is an engineering student. The other one is let me see what role I can. So engineering student, you're doing a lot of graphics, AutoCAD, ArchiCAD, and all whatnot. So if you're not don't know what AutoCAD and ArchiCAD is, those are software that are used by engineers to design structures, to design a lot of things. I sent a link out in the chat earlier. You see some components that are drawn out. Those are kind of software that they use to design some of those things. So one is into architecture and all that. Then the other person is, let's say Demilade is a lawyer. Yeah, it's a lawyer. So she's a law student. So if both of you want to buy computers, what will be most important what you should consider is this. What is the intent? What do you want to use it for? Now, you are a lawyer, you're only going to be typing, you're a law student, you're only going to be typing text, typing notes, and then printing off those notes. You're not doing anything graphic intensive, you're not doing anything memory intensive, you're not doing anything processor intensive. Now, processor intensive is the CPU. Graphics, somebody mentioned GPU earlier, that's your graphic card. Now, you're not also doing anything that is memory intensive. Now, there's some applications that will tell you for every software, for every application that is designed, there's what we call software or hardware requirement. So for that software, there will be a hardware requirement. The hardware requirement might be minimum 8 gig RAM, minimum 40 gig hard drive, minimum Intel Core i3 or Intel Core i5. If you don't know what Intel Core i3 or i5 is, I will explain it as we progress. That's a type of processor. So I will explain that as we progress. Okay. So for Demilade and Marilyn, this is what's going to now be the determining factor. What are you using your computer for? Obviously, the person that is going to be doing that's into architectural designs and all that will have to get a better computer. Like you get the RAM, iRAM, you get iROM, which is the hard drive or SSD or whichever you want to use. There are different types of storage devices nowadays. So to answer the question, Marilyn, it will be dependent on one, what you intend to use it for, and two, workload. Then to specifically answer your question, when you're buying a computer, what is most important? RAM or ROM. It goes back to what I said earlier. A lot of people have, let me bring this to your doorstep. And I'm going to tell every one of you on this call. I don't know what brand of phone you have, but a lot of us are on this call today that we are better off with just Nokia 3310. Stone me for saying that now, and I'll explain to you. If all you do is just make calls, text, and receive calls, that's all you do. Don't spend money buying a $1,200 phone, iPhone 13 Pro Max, right? You are actually underutilizing that device because you're not maximizing the potential, right? The same iPhone 13 Pro Max is what some guys are using to make crazy videos, like 4K videos, and that's all they rely on. That's all they use to make their movie, their films, or their video clips. And they do, what's it called, video montage and all whatnot. They go record wedding ceremonies and record, different kind of events, and they make money from it. The same device you have. So, Mei-Ling, so the question is, so back to your question. My question will now be, what do you want to use it for? What is the workload? If the workload is not much, like you're just going to be typing, I would say just go for something that is not that high. Because at the end of the day, if you buy something that high, you are underutilizing it, you're not maximizing the use, it's like a wasting of money. Did I answer your question, Mei-Ling? Thank you. All right. So let me see if I have any other question in the chat. Let me see. I don't think I have a question here. Yeah, all our responses. Okay, good. So let me move further as we go on. If you have questions, I'm keeping my eye on the question box. So don't worry, I have my eyes on the slide. I also have my eyes on the question box. So let's keep going. All right, so we've talked a lot about the computer hardware, and before we move to software, let me go back here. Okay, one more. Okay, before we go to the computer software, there's something that is very important that I need to explain to us. I'm sure you can see it on the screen. You can see what it's. You can see 32-bit. You can see 64-bit. So those are the ways in which computer processes information. Okay, and we have processors that are we have processors or operating systems, or we have software that are dependent upon that this information right here. I'm sure before now, all of us, some of you would have seen, you're trying to install some software and they say this will require a 64-bit operating system, 64-bit processor. And if you have a 32-bit, that for sure is going to be a barrier. But over time, there came the integration between 32-bit and 64-bit. Software developers are they now decided to start making software that would support both 32 and 64-bit operating system, whichever one you choose. So for example, you bring that software, you try to install it on a 32-bit operating system, it will install still. But before then, it was always an issue. So let me explain one of the things that also happened back in the day with the power supply of some of some of our workstations or computers back then. If you remember, if let's say anybody travels from the Western world, let's say from America, they travel to, or you're traveling from Nigeria, going to the UK, or going to, let's not say UK, let's say America or Canada, where you're going to have to use 110 volts and all that. So you're coming from a region. You're coming from a region where, okay, let it go. 64-bit handles more RAM than, absolutely. That's valid. Yeah, you're right. That's valid. 64-bit handles more RAM than 32-bit. Correct. So it's let's say that you're moving from Nigeria or from anywhere in West Africa where you have 220 volts is the standard power. Whatever device you're traveling with, you have to go with what we call a step down device, step down transformer to bring it down to the voltage of the country you're traveling to. Now, I am sure there's a lot of us, if you are, I don't know, I think there are a lot more Nigerians on this call. So let me bring this back home. I'm sure all of you on this call, if you don't know what I'm talking, if you know what I'm talking about, give me a thumbs up or just say yes, 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 yes. I'm just about to say this. You know how that somebody buys you maybe a laptop, sends you a laptop from the US, or buys you helps you to buy a laptop from the US and send to Nigeria, and then there was nothing called the adapter that comes with it. It's just direct to light, direct to electricity. Maybe let's say a TV. The first thing you want to do is you want to do what? You want to look for what we call a step-down transformer. Coming from the wall is a regular 220 to 240 volts, and on the other side of it is the 110 to whatever voltage that is not up to. And then where do you plug it to? You plug to the 110. Okay, there is the stabilizer as well, but the stabilizer is not what I'm talking about. I'm talking about the step-down transformer. Yeah, so for the step-down transformer, we step down that power to the standard of the country that the TV came from. If you make the mistake of plugging that TV to, thank you, Abel. If you make the mistake of plugging that TV to the wrong side of the step-down transformer, you plug it to the 220 volts, what happens? The next thing you hear is boom. Somebody says it's a blow. Thank you, Philip. So, but if any one of you looks at the computer power supply today, please, if you have one at home, look at the back. Look at the back of the power supply. It is something that looks like, let me take us a little bit backward. Yeah, it's something that looks like this on the side, power supply. You will see that it has a toggle. It has a red toggle on it that you can toggle to 220 volts or 110 volts. But back in the day, we do not have that flexibility on those power supply. But as people begin to travel, computers begin to travel from one region to another region, the manufacturers of those power supplies thought about it. Oh, what if we make this more easier for people to buy a power supply? And of course, it's valid because the majority of people who consume these products are in different parts of the world. So why don't we just manufacture something that if somebody is in the United States wants to use it, he can use it. If somebody buys it from anywhere in Africa, all of the continent could use it. It does not matter where you are. So that's where the advancement comes into play. So let me take us further into this and let me close with this. So starting us off with the software. I said all of that I said about the hardware to say this. Is this same as surge protector? Okay, I will explain what a surge protector is. So a surge protector actually, what it does is if there is a sudden fluctuation in power supply or power generation, instead of that power to be 120 volts, for no reason, it may be anything, it just surges up to 220 or 240. Everything plugged to that power supply or power extension or whatever that uses 110 or 120 will fry up. but the surge protector helps to limit that impact. Instead of that power to go out to all of the other appliances connected to that, what's it called, surge protector, the surge protector will take the heat, it will fry, and protect everything else. Does that answer your question? And all right, I mean Jane rather. Okay, so I said everything I said to us about the hardware, and now to get to the software. Look at it. You want to build a house. This is the house. Pardon me, I don't know how to draw. So you went to fabricate the house in Dubai, like fabricated everything ready. And then they brought you that house and just dump it on an empty land without a foundation. Okay? That will be you having a software without having a hardware. Okay, so you have a car, you don't have the fuel in it. It means you don't have a car, right? So what am I saying in a way? You see, every of those hardware that we mentioned earlier, they will remain there, like useless without the software to run them. Now, when I teach this, I used to say it like this, and I mean no disrespect to gender, I just like to use this analogy. Okay, take the hardware. Take the hardware as everything you can touch on the computer, plus the software. Plus the software. Both of them, what you can touch is the software. Both of them gives you the computer. Just in 1 second. Hopefully my whiteboard is not going to lose it for me this evening. Looks like something's going on here. Yeah, we are good. All right. So now the hardware and the software is what gives you what we call a computer. If you have the hardware and you don't have the software, forget it. You don't have the computer. If you have the software and you don't have the hardware to run it on, you equally don't have a computer. So what are we talking about here? Is a software like you all can see there is a collection of data, programs, procedures, routines, set of instructions, that tells the computer, take this, put it there, do this, do that, do this, do that, run this, execute this, and all of that. So in other words, every of those hardware that we talked about before, we talked about the processor, we talked about the hard drive, we talked about the RAM, we talked about the keyboard, we talk about the mouse, we talk about the monitor, we talk about all of those kind of things. Back in the day, we used to call, we have what we call a driver. I mean, we still have, of course, we still have drivers. Like when I say driver, I don't mean someone who drives. I'm talking about a software that drives everything else that is the hardware. Now, I'm sure people on this call, maybe when you used to use Windows, let me say if you ever use Windows 8, please say yes in the chat. Just type Windows 8, or Windows XP, or whatever operating system I mentioned. Yeah, Windows XP, Windows 7. Of course, that is recent. Okay, thank you. Yes, 7. XP, yes. I'm trying to look for one. Windows 98. Who did? If you use Windows 98, please put in the chat. I'm waiting. Okay, so if you don't have anyone for Windows 98, and I'm seeing Windows XP, fine. Now, what I'm about to say, you would understand better, and you can relate more with it with Windows XP. Back in the day when we had Windows XP. Oh, thank you, Job. Windows 98. Oh, please don't mention Windows 10 Pro. Don't worry about it. Don't worry about Windows 7 and 10. Just stay with Windows XP and Windows 98. Don't worry. Back in the day when we had Windows 98, you would need a driver for almost everything you run. Everything, almost everything. Like you're buying a let me see. You're buying this controller. It comes in. It comes with a CD-ROM like this. Remember, or it comes in it comes with a floppy drive. That's it. Your driver will be in your floppy disk. Sorry, it comes in the floppy disk. So the driver comes in your floppy disk. What am I saying? If you take this controller and take it to your game and you want to use it, your game will automatically ask you, give me the driver. Give me the software that I understand that would help me to function. You must install a driver. So it's like a bus without a driver. And let me bring this to our doorstep, okay? And I'll say it in two ways. So let me bring it home first before I bring it to the Western world. So home, yeah, the conductor is calling people to join the bus. The bus is going from Lagos to anywhere, Ibadan or whatever, name it. And guess what? 16-seater bus, I mean about passengers. 5, 6, 7, 8, 9, 10, 11. By the time it's about the 13th people, please, everybody on this chart, on this call, what do you think will be happening to, what do you think the people on the bus will be talking about? The driver is not sitting there. The driver is not sitting, but the conductor is calling people in. What do you think people will be doing? Put in the chat if you can preempt me. Thank you. Where is the driver? Thank you. No driver. Where is the driver? Oh, thank you, Jane. Where's the driver now? But guess what? The moment that bus becomes complete, what do you think the conductor will do? It will call for the driver. That's the reason. That's because without the driver, the bus will not move, and there are people on there that are going somewhere. Like, so my controller needs to work. My controller wants to work, but without this piece of software, this CD-ROM that has the driver in it, this controller remains nothing. Okay, but a piece of hardware. So let me keep going. Please remember, if you have questions, put them in the chat, and I'll try to answer the questions as we progress. So how does software work? I practically had explained that to you right now. It's just another term for computer program, and a program is a set of what? Instructions that tells the device how to perform. or what to do. The instructions are written in different languages that the computers can understand. I don't want to take into the different computer languages. We have low-level language, high-level languages, the different compiling structure or compilers and all whatnot. That is a story for another day. You don't need that information as of right now, but it will be very valuable for you to know that computer software are written in different languages. Okay. Now, so I mean, what are the common types of software we have today? I'm sure a lot of you will be using Microsoft Word. You'll be using, of course, all of us are talking right now via Zoom. That's a computer software. That's a computer software. It's a collaboration tool. It's a collaboration software. And apart from Zoom, Zoom did not pay me to do so. Apart from Zoom, we have WebEx, we have GoToMeeting, we have, there are a lot of guys out there doing this kind of stuff. And I know we have definitely we have, of course, School WebEx and all that. So we have Microsoft Teams as well. We have application software that is shareware. We have system software, of open source software, firmware, closed source software, programming software, utility software, driver software, freeware and shareware, and a lot more. So let me keep going while if you have questions, please feel free to ask me. Okay, now, system software is nothing but the base, the first thing that your computer needs to, like a foundation. That's what brings everything together. Then let it go. The question is, does operating system count as software? Yes, indeed it is. Yes, it is. Okay, and it is system software. So that's with the name it calls operating system. That is a software that brings every of the hardware that we mentioned, that brings them together. And I'm going to go into examples of those system software right now. I'm sure maybe a lot of you on this call will be using a Mac OS. Some will be using, I won't be wrong to say majority will be using Windows. I'm using a Windows operating system. I have my Mac next to me here though, but right now I'm on my Windows operating system. Some of you on your phones, you have your Android, and of course, TVs these days are coming with Android. They're coming with different kind of operating system. There's Google TV. There is Roku. There is Web OS. That's talking about TVs. So TVs too are coming with operating system, right? And just so you know, these are a few of some of the operating systems that we're going to be looking at. So I'm talking about Microsoft Windows, Mac OS, Linux, and of course there are many distributions of Linux operating system. So I'm just going to use that umbrella name, right? Because of course it's open source. You could have Demilade kernel of Linux, and when I say kernel, it's a distribution of Linux. So it could be just like you have. Thank you, Jane. You have Ubuntu. You have Red Hat. You have Fedora. You have Manjux or something. And then you have a lot more. CentOS and all that. So CentOS, and some people call it CentOS, but those are the operating systems. So that's the base that's what we keep everything talking to one another. Your hardware is talking to your mouse is talking to your keyboard. Keyboard is talking to the Microsoft Word or your word processing software. You're getting updates for different kind of things. That's the system software and application software. So I mentioned application software briefly in my last explanation when I talked about Microsoft Word and all that. So an example of application software would be Microsoft Word, Google Docs, Microsoft Excel, PowerPoint. I'm presenting using Microsoft PowerPoint. I mean, there are a lot of them, multimedia software. I mean, on this call, I'm sure a lot of you will be using Windows Media Player back in the day. Before we had VLC. There was, how many of us remember Winamp? If you remember Winamp, if you remember any of those, please let me know. Let me see if I can find that image and share with you all. Let me see. If you remember this image, I put in the chat. If you remember that, please say yes. So that's an example of application software as well. So going further, we have freeware and shareware. I mean, these are software that are provided for free use, for free users. But then, if you are the developer, Demlade or Jane, you're not giving that out to, you're not giving your source code out to anybody. Excuse me, please. You're not giving your source code out to anybody. You're keeping your source code. And what's your source code? Your source code is what you use to design that app, to design that software. So it houses everything how the software is built. It's the source code determines everything about the software, the way it is showing maybe the front end or the way it's relating with some other components in the back end. It's yours. Oh, fantastic. You said antivirus. Fantastic. You're right. That's an example. And I'm sure some of you use some antivirus software that are free, but it's free for you. But whoever it is, whatever company that owns the source code is not giving you the source code, right? So we have open source software. And what is the main open source software in the world right now? Who can tell me that it's common to almost all users? To majority of users. That's a pop quiz right there. There is one open source. Oh, the message I sent earlier was to X. I was going to send to everyone. There you go. This is it. Open source. Yeah, somebody said Android. Yeah, exactly. That's what I was looking for. Android. Good. Thank you. So it's open source. There is so much going on with it. With Linux as well, you can build your own. You can, you can tweak it. Have your own Ubuntu. You can call it Ubuntu or whatever. Just use it. Come up with your own brand. Come up with your own distribution, and push it out there. Let people use it. If they find it appealing, it becomes popular. Then everybody knows about it. Okay. I'm sure by now some of you will be hearing about GitHub, Stack Overflow, mean, these are sites that are offering open source codes and software codes that you can download and and use for your various uses and for different projects that you have. If you are not familiar with GitHub, please, that will be a great tool for you as you go in this journey. Let me somebody mentioned about BIOS before, but I thought I was going to get there, right? So in this final section, our discussion is going to majorly focus on BIOS, okay? And BIOS is the PC's most important startup program, right? Without the BIOS, everything that you have on the computer majorly will not be able to see each other, will not be able to see themselves, right? So basic input and output system, that's what it is. And it is the built-in core processor software responsible for booting up your system. Okay, BIOS is typically embedded into computers as a motherboard chip. That tiny thing, the person who asked about BIOS, this is coming to you. BIOS goes on the motherboard. Yeah. And of course, it functions as a catalyst for PC functionality action, right? It is programmed on an erasable, programmable, read-only memory, EEPROM. That's a chip, one tiny little chip that is erasable, it is programmable, and it's also read-only. Of course, it retains data for when the power is switched until the power is switched off. Okay. When the PC is powered back on, what does BIOS does? It retrieves the same stored data from EEPROM. Okay. Finally, the BIOS is responsible for managing the flow of data between the computer operating system and any device that is attached to it. I said that before. Without the BIOS, everything that makes up the hardware would not be able to relate with the software. Okay, so let me show you something real quick. How many of us have seen that chip before on our motherboards? The BIOS. Okay, Jim Larry Go says no. Yep. If you haven't seen it, if you have seen it before, say yes in the chat. So if you have opportunity of opening your, okay, we're getting a lot of yes. Okay, cool. But I also know that some of you, or majority of you people that have not seen the BIOS chip before, you would have seen the BIOS software window before, the one on the right. Jim Lightable, that question is to you. Have you seen the one on the right before? Because you mentioned that you haven't seen the BIOS before, but have you seen the one on the right before? Somehow. Yeah, kind of. Yeah. Look, everyone who I've not seen that person that will say, oh, I've not seen the BIOS before, but you haven't seen the BIOS, but you would have seen the BIOS software window. Anything could happen, maybe your hard drive crashed, or somebody unplugged something on your computer, or somebody, but even now we have what we call when someone opens the chassis of the computer, there is a setting in BIOS that will tell you that this computer was opened. So there's an alert that will come up the moment you turn on that computer. Because you know, we live in a world now that anybody could just enter into someone's house, take out the hard drive, quickly clone your hard drive. Oh, fantastic. Remilekun, that's good. Yeah, you press F8 while the computer is booting to go to BIOS. Okay, that is valid, but I'm going to also tell you this. It's dependent on the version of the BIOS. It's also dependent on the manufacturer of the computer, of the computer. Okay, so for some people, all you need to do is F2. Some computers, all you need to use is as the computer is booting up, F10. Depending on what I'm sure I've used some Dell before that I actually use F2 or F1, F2, and for some it's F4. Okay, good, you got it, Rebecca, nice. Okay, so let me move on to the next slide. The next slide will be questions. That's talking about the hardware and software of the computer.
Wow. Thank you so much, Benga. Great work. Great. We appreciate you, man. We appreciate you. Thank you. All right, guys. So let's get, like 4 questions. And I need you to raise up your hands with a reaction button. And you'll be unmuted to ask your question. Okay? 4 questions. I need to see your hands up, please. Can we raise up our hands? Adebayo, okay. Just like I said, I want you to raise up your hands. I know you guys have been communicating via chat, but we want to hear your voice. Okay? 1 second. Adebayo, please go for it.
So my question is, what's the difference between SSD and a hard drive? I used to know the hard drive, but most recently I've been, seeing SSD when trying to buy a computer. What's the difference between the two of them?
Benga, can you unmute yourself?
I was just about to unmute myself. Thank
Perfect.
you. So for starters, that's a very good question. So I have right here with me a solid state disk or a solid state drive, and I have a hard drive, an HDD with me, hard disk drive. So because of the computer evolution, like as technology continues to grow or continues to continue to evolve, we moved away from, remember when we used to have, I'm going to say something now very funny. There is, how many of us remember the zip drive? So this is your question now, the zip drive. That zip drive used to be 100 MB or 110 MB or thereabout. And that guy is massive and is weighty, right? But today, you have, all of a sudden, they came up with something called a flash drive that will take like 64 gig, you have 128 gig, you even have 1 terabyte hard drive now. I mean, flash drives. After a while, we came up with, where's my SD card? We came up with those microchip, small SD cards. So with the HDD and the solid state drive, the major differences are: 1, SSD is it has no moving part. This has a moving part. Major difference. Please take note. This has no moving part. This guy has what we call moving part. So this guy is faster, which is SSD. This guy is not as fast as the SSD. This guy consumes less power. This guy consumes more power. So as the requirement for space and read write speed increases, there is need to reduce it, because this guy will generate a lot of it. I put it away. This is your guy. In fact, if you look right now, the evolution of hard drives, there's not even SSD. SSD will be going away very soon. We have M2s. So let me quickly send you what the M2 looks like. One second. Just want to send you something in chat for everyone to see. You asked a very valid question. Did you? Yep. So look at this real quick. I'm putting this in the chat for everyone to see. And then let me do something. I'll also make it with 1 second, HDD. Yep, that's it. I'm putting this back in the chat for you guys to see. So because of time, those links will definitely help you to understand the differences between M2s, SSD, and the HDD. So like I said, the technology is moving so fast that what we used to know as the hard drive, that massive hard drive, is going away, and everything is becoming replaced with, like, I'm sure right now, not many of you on this call have your laptop with CD-ROM drive. If you have your laptop with CD-ROM drive, say yes. Type yes in the chat. You know why? Because everything is becoming thinner and lighter, less requirement for power. You want to consume less power. So if you still have your CD-ROM in it, maybe you bought that laptop like I'm sure your laptop will be about 7 years old. Or 8. If as a matter of fact, some laptops now, they are even removing the network interface card from it. They don't come with network card anymore. So instead of having a network card on it, what you get is they give you a dongle like this, USB Type-C, that you connect to your laptop, and then you have other ports in there, like that. And then your power, your network card and your display port. So did I answer your question, sir?
Yes, you did. Yes. Thank
and
you.
Also, no worries. I also use your question to answer some other question. I'm sure somebody else will have another question. Oscar, do you want me to call the people with their hands raised? Okay, so I can go with Adebayo. Go for it. I can see your hand up. That was Adebayo that just asked the question. Adebayo, go for it.
Yes, you already answered my question.
Okay, good. Okay, fine. And then Martin?
So, Martin, go for it, please.
Yeah, thank you so much for taking us through the training on the computers and everything. I just want to ask about how to identify safe and unsafe softwares, because I know you've taken us through a couple of softwares that are available out there, and sometimes some are open source, some are free, some are you have to pay. Now, we know that there are some unsafe softwares that when you download them onto your system, they can crash your system or introduce some malware stuff. So how can you tell safe and from unsafe software to protect your system?
Okay, fantastic question. Fantastic. This man is actually taking me through. It's taking us to a point where we'll be getting to it later. But let me explain this right where we are. I want everyone on this call to desist from installing software that are non-signed software. software that you don't know their source. Random sites can just put up some, and again, be mindful of the freebies, because not everything that is free is good, right? If I want to write a malicious code and I want to gain access to 1,000,001 computers today or tomorrow, I'll put that malicious code into a free software that is appealing to a category of people. And I would then have an opportunity to introduce to them what you call a malware. Thank you for bringing that up. I also have an opportunity to put what we call a payload on their computer. And this is going to bring me to this. How many of you have seen a lot of WhatsApp broadcasts going about that some company is sharing some freebies and blah, 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 blah. Click on this link and all this kind of stuff. And then when you click on that link, they tell you, download this. Those are ways that hackers get access to a lot of people's devices, be it phones or computers, without you knowing, and dump a payload on your computer that's going to be executing some commands and some things for us in the back end, and you can take control of your computer and all this kind of stuff. So to answer your question straight, be mindful of freebies. 2, buy software from the accredited sellers. Don't buy what you know as pirated software. That's a big one. Non-pirated software, buy from the source. If you buy from the source, you are sure of always getting the right software. Martin, did I answer your question?
Yes, thank you so much. Appreciate it.
All right.
Excellent. Buy from the source, buy from the OEM, buy from the manufacturer, buy from the vendor. Okay, a lot of third parties can be subject to phishing or subject to malicious websites. Excellent, excellent, excellent. Any other question? We need a lady to ask a question. Then we continue. A lady. Where are the ladies with coconut head here? Chinwe, Dorabo, where are we? Motiat. Do we have any question? All right. Okay. In the absence of that, Benga, do you still have a couple of things?
Yes, I do. Mailing just said in one of the classes we were told we can partition our computer. Please, how can I partition my MacBook? Fantastic. Okay, so Mailing, you're going to lead us into what I was going to go to next, but that's fine. I'll use this to answer a question. There's a tool for dual boot for MacBook. So I'm thinking that no, sorry, you don't need to be sorry, Mailing. You're good. You asked a very valid question. That's okay. So I'm sure there's there's what we call dual boot for Mac. So for every Mac user, please Google dual boot for Mac. Okay, I should share it here. Okay, use Mac too. Martins, good job. Martins is an Oliver too, right now. Okay, I'll share it with you right now. 1 second. Just 1 second. I'm putting that for you guys. And it's also parallels. So, and I'm actually going to put in here for you an Apple support link for how to do that. Just right now, I'm starting with the Apple one. Remember what I said? Go to the source, and also concluded from I said go with the OEM. So I'm not sure if you want to go with parallels, but it will be a good one for you as well. Let me give you parallels as well, but I used parallel in the past, but you know, oh yeah, it was so frustrating I couldn't participate in the Power BI class. I'm sure after this class you'll be able to have your Windows on the other side as your Mac. Okay, all right. So any other question? Any other question? Shaka, I see your hand up too. I see your chat. That's fine. I'm sure you guys that have that's using Mac, you can definitely leverage the link I just sent you now to have dual boot on your computer. Okay. Any other question?
No, let's continue.
Okay, so I'm gonna go over and share my other screen. Let me stop sharing now. Before we go into what is it called? Networking tomorrow. We need to lay some very good foundation before we get there. Share screen. This guy. Sorry. What is that? Yes, and I have it here. Good job. Thank you. Let me make sure to close the first one. Just give me a second. Just getting things ready. Okay, that's it to share. I'll start it up again. Yep, we should be able to share now. Share screen. Yep, we have it. Okay, can you all see my screen?
Yes, we can.
Thank you. So this is just a quick recap of the operating system, what I've talked about before. Okay. The reason I did this is so that you can have a full grasp of the entire thing before we get into networking. There's the hardware, there's the software, there's a relationship between the hardware and the software, and there's a role the operating system plays in the relationship between the hardware and the software. Okay. Now, this is just for you guys to take it in, right? So this might look like a little bit of repetition of what was talked about before, but I just want to take a few minutes from what we have left to quickly go deeper into the concept of operating systems. Okay, I've told us this before, that this is the most important software that runs on any computer. Yeah, it manages the processor, the memory, and input and output and everything. It allows computers to communicate, you know, easily and with the computer languages. All right. Again, I like this point. Without an operating system, a computer is what? Is useless, completely useless. Okay. We've talked about this before, different type of operating systems that we have: Microsoft Windows, Microsoft OS, Mac OS by Apple, Linux by, you know, we have all kind of operating systems. There's Apple iOS, there's Google Android, and there's Windows Mobile for telephone, for phones. And of course, all of us know that we had the other one for BlackBerry, RM, you know. Okay, so this particular diagram is what I want us to pay attention to. But take your attention away from everything on the side. Look at that thing in the middle. It says what? Functions of the operating system. Then let's now look at the wings. From the middle, let's build it out. To the left, process management, memory management, file management, device management, security. I'm going to take 3 right there. Process, the one that is that I'm taking this to your doorstep, everyone. Process, management, file management, and device management. Every time you say, you type, I want, Dr. James, I'm happy to write to you, blah, 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 blah. As you're typing into a word processor, like Microsoft Word, WordPad, Notepad, or it could be an HTML editor, whatever that you're using. Computers don't understand A, B, C, D, E, F, G to Z that you're typing. No. The only thing that the computer understands is zeros and ones. So it is the operating system that is managing that process. Okay. Now, as you're typing on your keyboard, you are typing alphabet. But guess what? The computer only understands zeros and ones. So the central processing unit processes all of those things with the help of the operating system to make it make sense to the word editor that you're using, or the processor that the word editor you're using. It could be Microsoft Word or any other word editor that you're using. Now, file management was the second one I mentioned. You move your mouse to right click on your mouse and say copy. We'll go and paste that thing you copied into a different directory, different folder. Boom. Without the operating system, you cannot do that. The third thing that I mentioned was device management. You have your flash drive. You want to copy something. Oh, fantastic. This is a very good example. How many of you at one time or the other, you were working, you had something saved on your laptop, on your or on your workstation, your desktop at home, and someone reached out to you. Can you please copy that file and put in a flash drive and send it through somebody to me or something? And you got to your computer, you turn it on, and guess what? It won't turn on. It won't turn on. If the answer is yes, please say yes in the chat. And it won't turn on. Were you able to get your file out of that computer? You can't, because the operating system refuses to boot. And if it doesn't boot up, you can't get the file out. So that's file management. So let's go to the right. Job accounting, secondary storage management, process management, networking, which is where we are going. Networking. Now, that is a very important part for us tomorrow. Networking, the coordination between other software and users. Those users could be local users, they could be domain users, they could be network users. So we are showing this, talking about this to prepare the ground ready for what we're going to talk about tomorrow. So remember, tomorrow we're talking about networking, but it will not make sense to you for us to just jump into networking without laying that foundation of what the hardware is, what the software is, and what the operating system is. So
that will be on Sunday, not tomorrow.
Oh, thank you very much. I'll keep talking about tomorrow. It's Sunday. Yeah. Thanks, Oscar. I'm excited to jump into it.
I know.
Okay, so during the network class, you'll be seeing a lot on CLI, but I need to clarify it now and wet the ground ready before we get to it. There's what we call CLI, command line interface, and there's what we call GUI, graphical user interface. Now, I'll take it from the latter, GUI. The GUI is what you can relate with your mouse. Like you can take your mouse and move, click, 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 drag, drop, right click, delete, right click, copy, right click, paste, right click, cut, right click, paste. So you can use your mouse to do all of that. That's the graphical user interface. You can relate with it like it's saying accept, yeah, okay, you can click on it. No, you can click on it. So that's the GUI. But the command line interface is where you use codes, you use commands. It's black and white. Like you have to type, you have to know the commands to type it. But good for us these days, you don't have to remember all the commands because there are reference guides for us. So when we get into that network class on Sunday, not tomorrow, on Sunday, remember, okay, I'm working myself back now. So when we get into that network class on Sunday, you will see me do a lot of stuff using command line, and I'll also show you fantastic day. I'm a Korede. Thank you for putting that in MS-DOS. Thank you. So if you ever use Windows 98, you will appreciate how it was then. You appreciate how easy it is now to install your operating system, because then you have to install your Windows 98 using commands before you can get to the GUI. Okay, so a CLI operating system is one that makes use of command line interface to perform tasks. A good example of a GUI operating system is Microsoft Windows. CLI is Linux. Thank you, Jane. CLI is Linux. So let me keep going. Okay, now let me say something here. One major advantage of CLI over GUI is faster performance and execution of tasks, while a major disadvantage is the unattractive look of the CLI interface of the CLI. Okay, now this is it. The GUI is how do I put it? It's appealing to the eye. Like you love graphics, it's there. It's simple to operate. You can easily get around it. It's easy to operate. You don't need to learn some codes. You don't need to open books. You don't need to spend hours and hours and days understanding what it means to boot up a computer. You know, let me put it to you this way. Everything you click on your Windows computer, there's a command for it in command line. So if you use Windows 10 or Windows 11 right now, just so you know, there is an operating system, is Windows, a server operating system that is just purely command line. The same thing you do, like copy, paste, right click, new folder, name the folder. You can do the same using MS-DOS. So you will understand this, you will appreciate this better when we get into the network class on Sunday. So let me take us a little further. Now, CLI versus GUI, for everything I've said. If you look at what's on your screen right now, the GUI, like I said, is modern, is appealing to the eyes. There's so much colors involved. There is the images are clean. You have scroll bar. You have different highlights. Everything that comes to you is a yes or no. It's either okay, cancel, It's graphical. You can see it. You can easily relate with it. Okay. Now that makes it a lot more user friendly, and that's why a lot of people today in the world use the Windows operating system because it is more user friendly. You can relate with it. Your 5-year-old, your 4-year-old, you can simply just put your 5-year-old or your 6-year-old on your computer for them to take classes. Let's look at it this way. Let's imagine that pandemic struck in 2019 and we didn't have anything called Windows, and kids will have to study from home. I'm sure even kids and adults will struggle to use Linux. How many people on this call, how many of you are Linux users? If you're purely a Linux user, you don't use anything other than Linux, please type Linux in the chat. Type Linux in the chat. That's all you use. You don't use anything. Okay, nobody. All right. So that shows you how advantageous the GUI is over the CLI. The CLI, again, is the command line interface. The GUI is the graphical user interface. You can easily relate with the GUI. It's especially with the graphics. It's beautiful. It's there. But the CLI is boring. But as boring as it is, a lot of us are in love with it. You'll find out on Sunday when we get into the network class. Okay, so let me move on to the next slide. GUI versus CLI. Look at that screen. One on the left is the GUI. The one on the right is a CLI. So CLI rather. So pardon the typo. So if you look at the graph, the image, the one on the left has beautiful colors. You can relate with the icons. You see those icons, and the beauty of things is the more you move your mouse closer to the icons glow, they pop up. I mean, the user experience is there. So Microsoft is evolving. They're making it more beautiful. What's it called? Apple is doing a great job too, making sure that their command line is beautiful. But I mean that the GUI rather is beautiful, and the user experience is fantastic. But look at the command line. It's just there. It's just some text. It could be green on a black background. It could be white on a black background. But guess what? You can also change the color of the text to how you want it. But it's just text. That's it, plain text. And you have to type your commands yourself. Now, quickly, I'm just going to take us through the boot process of the operating system. It's CLI for me. I mentioned that, pardon the typo, it's CLI. Thank you. So if you look at the boot process, for me, did I answer your question? Okay, so if you look at the boot process of the operating system, there is a process for the operating system to boot. The first thing is it loads the basic file system drivers. It loads and reads configuration file. It loads and runs supporting modules. It displays operating system menu, and then finally load the selected operating system. I am sure a lot of you on this call, as you've turned on your computers before and you see missing operating system. What that means is your operating system file could not be loaded. And at that point, you need an engineer to come and I used to play that role in the past where I install operating system for people, or they say, oh, my Windows are crashed, my computer are crashed, my system can't boot again. But majority of the time, it's not that the hard drive had crashed or the OS had crashed. It may just be that they move the computer around and the IDE cable. Hey, let me not say some big things here. Like the cable that connects the hard drive, to the motherboard probably shifted. And I just open up the chassis, check the cable, put the cable back in place, power it on, and then boom, it loads the file system. The moment it loads the file system, everything else will follow that process. That's what we call power, and then to go through the post power on self-test, POST. The moment you turn on your computer, you see some black screen showing you the version of the BIOS, the year of the BIOS, the manufacturer logo on a black background, and the rest of the text is white. It tells you your hard drive. That's why you see press F2 to go to, or press F2 or press F10 or press F8 or whatever. At that point, the computer is going through what we call power on self-test, post. Okay. I'm going to skip through this because I've explained this previously. All right. The following are some of the tasks performed by file management of operating system of any computer. It helps to create new files in computer system and placing them at a specific location. Something I mentioned that just right now. It helps in easily and quickly locating these files in computer systems. It makes the process of sharing of the files among different users very easy and user-friendly. And I'll quickly go to the last one. It helps the user to modify the data of files or to modify the name of the file in the directories. I'll go to the next slide. This is more graphic, and you can see a lot of things when you are in the operating system. Okay, now I talked about the directory earlier, and I'm sure a lot of you know what a directory is. You may not just know it as a directory. You will know it as a folder. Okay, now if I have a document folder, like root folder, my document, I'm sure all of you in that uses Windows 7, Windows XP back then, you remember that there's a folder called my document. That is a root folder for all your documents. And then you create different folders in my document. You call it directory number 1, directory number 2, directory number 3. That's what you're seeing on my screen, on the slide. So that directory number 1 could be my school document, my budget document, directory number 2, directory number 3, family pictures or something. As a matter of fact, there's another root folder for my pictures. So let's not put family pictures there. So that could be my travel document, something like that. Those 3 directories are sitting right in the root directory called my document. Now, inside each of those directories, you now start creating what we call files. And then you also create what we call subdirectory. So any folder you create in the directory number 2 is another subdirectory. Okay. Let me move on. The versions of the computer OS. I talked about this earlier, and I said I was going to talk more on it. So we mentioned Windows we mentioned Mac, we mentioned Linux, and a lot of things are that we need to take note of before. Let me go back before you start to talk about installing the operating system on your computer. You need to know what your computer supports, whether it's Windows, whether it is Mac, or whether it is Linux. Okay, and I'm sure that there'll be questions right after this. I have like 10 more minutes to wrap up, and I'll try to wrap up in 10 minutes. So installing and updating your operating system. In this lab, because we do not have, we're not physical, we're not right, and we're not doing, we can't demonstrate the installation of the operating system, but I would make sure to prepare something that I'll share with you all on Sunday that that will show you all you need to do when you are going to install your operating system, and you'll be able to do it yourself at home. If you ever, if your operating system ever got crashed or something, or you just suddenly can't, it just wouldn't boot, and you want to be able to recover from it, or you want to reinstall your operating system. So on Sunday, I'll put that in the chat for us. I'll get that ready and I'll put that in the chat for us. Okay. So question.
Awesome. Benga, you've done great tonight. You've done great.
Thank you.
Really appreciate you. I didn't know that you fire on up to this hour, man. You know, the energy, the passion is incredible. And that is something about passion, guys. When we talk about passion, we talk about, like, you know, you are trying to pivot into tech. Always look at areas where you've got some skill set and areas where you are passionate about. When you are passionate about something, trust me, any day, anytime, somebody will wake you up, you're able to talk about it. So Wenga have done excellently tonight, you know, breaking these things down for us, operating systems, softwares, name it. Now, the truth of the matter is the fact that tech, just like we keep saying, guys, is broad. For some of you, remember the essence of what we are doing. This program is not part of what Black Tech offers, IT Foundation. But we have simply put this together for those that require some fundamental insight and understanding. That is the essence of this. Okay? And it's an opportunity for you to ask as many questions as possible. For some of you, what we have done tonight might not be relatable in terms of what you are eventually going to be doing. For example, you probably might say, oh, I want to become an IT auditor. I don't care about RAM, ROM, Linux. I don't care about all those things. Or I want to become a GRC, you know, governance, risk, and compliance. But the truth of the matter is this: for you to be a well-rounded tech professional, it makes sense to have understanding of different areas in tech. Then you now have a specialization. Specialize in one area, that becomes your specialization. Why have understanding in different areas, so that when you are in a boardroom or there's a conversation, people are talking about some of these things, you should be able to say something. Remember, one of the career killers in Canada is when you are in a meeting, from beginning to the end, people are talking, contributing, and your mouth is quiet. It is a career killer. You must say something, even if it's even if it's to rephrase what somebody else have said. Rephrase and say it, or comment, or even appreciate You must say something. This is not an environment where you just be quiet. Say, make I just keep quiet. Make I do my. No. Canadians love it when you contribute to discussions. And the truth of the matter is this. There are some topics that might not be within your area of specialization. But if you have small understanding, for example, some of you that attended Power BI the last time, if there's a conversation anywhere and somebody is talking about Power BI or visualization, you will be able to say one or two things. That is it. And here we are today talking about RAM, ROM, Linux, Windows. Somebody is talking about Windows. You will not be asking, is the window in the house or the door? No, Windows operating system. Somebody asked a very good question. Can we also call operating system a software? Yes, we can. Those are great insights you can contribute during discussions. We want to see well-rounded tech professionals, knowledgeable, confident, and you are able to, have conversation. That's really what we are trying to do here, helping you guys. And for some of you that wants to register for our ongoing programs, especially the ones that are tech related, cybersecurity, cloud computing, DevOps, you need IT foundation. You need the basics before you can delve into those areas. And that's really what this program is all about. So Benga, thank you so very much again. Guys, I was expecting that by now, the chatbot should be, I was expecting that the chatbot should just be, what is going on? How many? I can't even see any thank you from anyone here. Only about 2 or 3. What is going on? I thought the chatbot should be on fire by now. Chiwe, you are doing LO. I said, you are doing laugh out loud. What is that? Can we appreciate this young man for coming on board today, irrespective of, his tight schedule and some other thing that came up. But still, he said, no, Osita, we are not postponing this. I will be there. And eventually he's here, live and direct. Let's appreciate him, for he has done a great job tonight. Okay? Osita, we are waiting for you to finish talking. How can you wait for me to finish talking? When you see my voice is cracking, you say you're waiting for me. All right. Thanks, everyone. Benga, excellent delivery. Excellent delivery. We really appreciate you tonight. Thanks for everything you've done, man. We really appreciate you.
I think you have the hand up.
Yeah, let me allow folks now to be able to unmute themselves. And also technically, we are going to be wrapping up this session. Officially, the session is ended by 9:18. Yeah, it's ended. So let me stop the recording at this time.